Hello everyone, and welcome back to another video where we talk about grade 9 math. In this video, we're continuing our topic on linear functions, and we're going to be discussing the idea of gradients and introducing the gradient formula. So gradients are basically how much we change in the y-axis for every unit of change in the x-axis. In simpler words, it's a number that tells us how much we go up and or down in our line movement for every single movement forward on the x-axis. So for every one unit of movement on the x-axis, we want to know how far up or down we go with our line. And gradients are usually given the letter m, and the way we go about calculating this gradient is, if we see our line, we find 2 points that are easy to read. And what I mean is, let's look at line A, for example. If I start from the beginning of the line here, and with my eyes I move on the line, I want to look at every point that is easy to read. As in, if I pick this point, I can easily tell that it's at -3 on the y-axis and -2 on the x-axis. Over here, I'm not very sure, because if I zoom in with my eyes, it could be crossing the corner exactly, or it could be a little bit to the right of the corner. This is easy to read. So this is an easy line to read because there's almost every point I can find its coordinates. If we look at line B, for example, however, it's not the same way. So if I start here, that's easy to read. Over here, that's not easy to read. I'll have to get either zoom in more on my coordinates to be able to tell a more accurate number, or I can't really get an accurate reading right now. If I continue, this is also easy to read, and the last point is also easy to read. So you get the point. So let's find on the A line, back to the A line now, let's find 2 points that are easy to read. I'm going to pick these 2 points here, and we want to draw a little triangle, right angle triangle, that connects those points together, like this. Okay, so this is a right angle triangle. And then I'm going to just measure how much the y is, as in the height of this triangle, which is 2. And then measure how much my x is, as in the base, which is also 2. And then I'm going to divide. So now we're getting to the point where we actually get the gradient. So I'm going to divide the y by the x, which is 2/2, which is 1. So my gradient for line A is 1, meaning that every time I move 1 step on the x, I also move 1 step up on the y. All right? Now let's try that for line B. So before we get to line B, to actually getting the gradient, I want you to try to think, take a minute to think if the gradient is going to be different or the same. Is it going to be less or more? So take a moment, pause the video, take a moment to think about that and give a reason, try to give a reason as to why you think what you think. Okay, so gradient, another word for gradient that we don't usually use in questions, in math questions, gradient is just the steepness of the line. It's a measure of how steep the line is. So imagine you're walking up a hill, and the more steep it is, the harder it is to walk up, right? So just by understanding that, we can tell that line B is less steep than line A, which means that it will have a smaller gradient than line A. Now let's actually calculate that and find proof for our thought. So I'm going to do the same thing again. I'll find 2 points. These are easy to read. Make my triangle. I don't need to make the base. So I'll just count the height now, which is 3. Counting the base goes from 2 to 7, so that's 5 steps. So for B, I'm going to divide 3 by 5. Now I don't need to put that in a calculator, it's just a fraction. So it's a fraction, which means it's smaller than 1. So this proves, if we do it on a calculator, it's going to be some kind of decimal. So this already proves the theory that the steepness of B is less than A, so its gradient has to be less than A's gradient, and A's gradient is 1, so B's gradient has to be less than 1. All right. The method we are talking about, by the way, has a name. It's called the rise over run method. Rise over run. So it helps you remember what to do, because rise meaning up and down, all right, which is the movement of y, and the run means forward. So that's the x movement, because x moves horizontally and moves forward. All right. Another thing we need to know now is that the sign, whether the gradient is positive or negative, is very important. Because if we look at line C, now line C at the moment, can you tell what's different between line C and lines A and B? The answer is that line C is moving downwards, not upwards. And that matters because we need our gradient to tell us how far up or down we're going when we move forward on X, right? So if it's moving down, there has to be a way for the gradient to tell us, oh, we're actually moving down. And because we move down, the gradient is going to be in the negative. So as we move one step forward on the x-axis, we are actually moving down on the y-axis. So we want to know how much down we go for every one step forward on the x-axis. But the way to actually get the number is exactly the same. So I'm still going to find 2 easy points. Here's one. Here's another one. Still make my triangle. I'm still going to count the height for y, but this time, this height, I'm going to write it in a negative. So it's 3 steps, but it's 3 steps downwards, which means this is minus 3. We went minus 3 as we moved forward. So we write minus 3 divided by, and then it's also 3 on the x-axis. The x-axis, the value for x is always going to be positive because our lines always move forward. So when we plot them on coordinates, Cartesian planes, the lines always move forward, but as they move forward, they could be moving up or down. Okay, so the x here is 3, so I write it, and then minus 3 divided by 3 is minus 1. So the minus remains. All right. Now, the last thing I want to talk about is putting all of this into a formula. So the gradient formula, when we're dealing with linear functions or lines, straight lines. So assume we have 2 coordinates here, which is what we're using, right? So we have 2 points. I'll call the first one, I'll give it coordinates x1 and y1. And the coordinates for the second point are going to be x2 and y2. The gradient formula says that the gradient m equals y2 minus y1 divided by x2 minus x1. So we're going to look at a couple of examples next video where we put this formula into practice. It's not different from what we just did right now, but the reason we introduce the formula is that sometimes in questions we are not given the visual of the lines, so we don't actually see the lines, we're just given coordinates, and we need to know what to do to get the gradient when we just have coordinates without needing to draw our lines. All right, I hope this video was useful, and I will see you in the next one.